Good evening, all. Basically, see, R&D, pilot plant, technology development, process engineering, procurement, and execution. These are all complex teams working together. So I'll try to, go in a sequence manner. In my, 23 years of experience in the growth projects, basically. So growth projects, I mean that which are, business growth related projects. So R&D, basically, if I start there are three types of technologies which are there. So technology transfer which comes to R&D, like one is a directly license-driven technology, where you have a licensor who is giving the technology directly. So there R&D has the least role to put on. So mostly R&D is not required in that case. The second type of technology is transfer is agrochemical, basically in batch processes. So batch processes, it can be a contract manufacturing, developed by a client which you have to develop and you have to demonstrate in your R&D. And the third kind of technology transfer may be in-house molecule development. So it has nothing to do with a client who has already done some work in the molecule development or product development. So first, we don't need to do any R&D in that case. Second and third are the most painful job. And the third is the most painful in terms of second. So we have to, we have to see what level of instrumentation. In the earlier speaker was having some discussions about the innovations. So basically, what kind of R&D level we are having in present chemical sector. So we don't have, still we have R&D which is quite old. We are doing reactions in round bottom flask. And the data which is driven by that, reaction is not being, grasped by the pilot team. And there are issues with respect to scale up. So one fine example, if I take that, if I ask my piloting team that in 5 years before I had, I joined a company where there was a report which shows the pilot data. So he completed the entire piloting of 3 batches of 5 stages product in 7 days. So I was very surprised. So how you completed this activity so fast? And so I visited the pilot plant and I asked him which equipments did you map. So he stand in front of a reactor and he told me this one. So there were 5 stages. So I told him again. So where are the other reactors? So he said this one. So entire piloting he did in the same reactor. So reaction, workup, crystallization, everything in the same reactor. This is how we are doing the pilot. So this is not the way of, so the answer to the question question number 1, Praveen.
Yes, sir.
So by doing that, this kind of piloting, the tech transfer guy doesn't have any data when he makes a layout. So when he makes a layout, he doesn't know, 5 stages, which product is transferable, which is a slurry. So he doesn't think that there is a gravity control. He installs a pump for the transfer after the reaction. So when after some time the plant starts, the material is not getting transferred. So then again it goes back to the pilot. So have you seen the pilot? No sir, मैंने तो सब एक ही reactor में किया है, तो मैं कहाँ से, I'll not be able to get the data. So in commercial scale, we are having, because of the capacity, time cycle constraint, we are dividing each stages, reaction, workup, everything in separate reactors or separate batch equipments. So these are the challenges which has to be answered in the pilot and the R&D scale. Now coming back to R&D, so R&D and the pilot. R&D is heating the round, taking the reactions in a round bottom flask. You have a electric heating system, and the delta T of the reaction, the electrical heating system is huge as compared to plant. So if I say technically, the surface area of a round bottom flask meter square per meter cube is far greater than a commercial reactor of 16 KL or 20 KL. So that is the reason why we have a time cycle increase from lab scale. Lab वाला बोलता है 1 घंटे में मैंने reaction हो गया sir, cooling हो गया, but we are not able to achieve in commercial scale plants. So these are the basic issues in the understanding related to mixing in lab. So lab we have, everybody knows, a lot of you are chemical engineers, we have a half moon agitator in lab where we don't have efficient mixing at all. So, and the RPM, if you'll say, the RPM would be like 700 RPM. And if you scale up the same thing in the commercial scale, you will end up with a very high settling velocity, very high power per unit volume numbers. So this is the pain in the scale up. If you are not able to observe things correctly in R&D and pilot, then you are going to mess up in the commercial scale. So I can speak this 1 hour continuously on scale up and what issues can come in the plant scale when you have not done pilot, because that delays your execution, that delays your commissioning. So I think I have answered the question. Any question is as is remaining?
I am just asking if you want to add anything on what Kapil ji has said.
Okay.
So coming to sir's point, so what happens? Ki when we do kilo lab and we go for piloting. So in pilot, everybody have their own pilots, but they don't have everything. If you have a distillation, there are 50 types of distillations. If you have a reactions, there are 100 types of reactions. Filtration. So everybody will not have all the facilities. So I am agreed with sir. We should have a piloting. Kilo lab is okay. It is your subject, but piloting should be at a common facility. So he should have a filtration, 10 type of filtration, distillation, 15 types of distillation. So from kilo lab to going to the big scale, it is not good thing. We should have a piloting, and pilot is also having sufficient equipment. So that anybody, if any industry will keep pilot, he will not have everything. So we should have a common pilot plants. They will equip with the all things. Yeah, we should have a filtration. So we should have 10 types of filtration for piloting for only filtration, piloting for only distillation, piloting for only drying. That type of setup we should have in our industries or at a common places. Then only we can solve these problems. Yeah.
Sir, one addition question to you is, I am taking the another, which this question was with how to design projects to minimize future problems, plus legal compliances requirement.
So project design, generally what we are doing, after receiving of CapEx, we are hiring the designing consultant. So this is not the right thing. See, for designing or for prior designing, we don't require so much of money. So if we have any plan or any plan, so we should have a little bit capex in advance. So what we are doing, when we have a capex and we are ready, land and everything is ready with us, then only we are hiring the designing consultant. And parallelly, we have lean time, we want everything. So in designing stage, we should spend so much of time, and nowadays 3Ds are also available. So we should hire that consultant who can give us the 3D. So, and in that case, all the teams, operation, maintenance, everything should be involved in that 3D designing and everything. So when we are doing something, I seen many of the projects, their project manager doing everything, but production manager or maintenance manager, they are not aware of anything. So they should be aware from day one. So they should also give their expertise during the project stage only. Then, and if we will design properly all the equipments and everybody are involved, then I don't think after installation of the equipments or everything, we should have so much of time. And definitely, piloting is done properly. Sir said, we don't know that this product will be pumpable or not. And we keep their pump. So if piloting is done properly, then these all things will not come. So we should spend a lot of time in the designing stage. Execution is not so a big thing. We can execute very fastly, but we should, if we will give proper time and with proper teamwork in designing stage, then we could achieve all the problems without, yeah.
Kapilji, if you, yeah, please.
See, lot of you might be in projects and execution. See, there are only two gaps which you will find at the end of, any execution, a cost escalation and a timeline. Okay, these 2 points will going to harass you in any project. So please try to understand, if you go in a systematic way, like, see, so we have developed one culture in Jubilant. So if you are not sure, or if the management is not sure to approve the capex, okay? So for example, you have a 200 crore of capex, and the management is not sure about the business. So at least spend 5 crores out of 200 crores to bring that capex to approximately plus or minus 10% of pre-capex activity. Like, you generate a pre-capex, give it to a consultant of 5 crores, tell the management, don't give me 200 crores, because whenever capex gets, a value of 200 crores, your management tells us, I am not going to accept it. It's too high. Bring it down to 150 crores or 100 crores. So, with respect to that, with the help of a third-party consultant, whatever you can do is, you can generate a pre-capex with a detail engineering up to plus or minus 30% of, with a 30% isometrics being completed. So at that stage, up to 30% isometric completed, mapping completed, you can at least generate plus or minus 10%. So in that, you have your PNIDs, done, your layout done primarily, and major piping is done in 30% mapping. So that will, and after that, you will generate a capex, which is plus or minus 10%, and which you can show to the management. And with that, if you start the zero date, then you will end up with 12 months. You understand? So don't, a capex has been approved, 200 crore approved, you start detail engineering. So detail engineering is not completed because you have not started basic engineering. So you will take at least 4 or 5 months to do the basic engineering part to come to an extended basic engineering. And then you give the documents to the consultant. So once the documents, consultant gets, it takes again the, GA drawing and everything to make the layouts. So it takes around, 7 months for the consultant to start the work.
The third question was with respect to new technology options. And the person beautifully put is low initial cost and high operating cost, or is it high initial cost and low operating cost? What would you opt for, sir, Anil ji? Aarti mein kya hai model?
I wish there was a simple answer. So I think this is, I think one of those mirage probably that everyone starts chasing when the project is there. I think in my experience, what is important is that how people start collaborating in the initial phase. In the typical project cycle that we see, as my fellow co-panelists shared, people start with basic engineering, detail engineering, and the technology selection merely becomes a technical decision, I would say, and when the things are passed on to the commercial functions, then the new technological evaluation, and I'm sure, a lot of project and engineering functions have gone through this pain that, procurement functions are adding new technology, new options, right? And I think all such kind of pains actually emerge because whatever needs to be done at the strategy level, which is when the project is being decided, all those activities are postponed to the transactions. Now, I think so first and foremost is that when the people are actually building a project, what are they selecting for? And, I think that's a very, very initial and project strategic decision wherein all the cross functions should come together, decide what makes sense techno-commercially. And as, many of us would always do a business case analysis for a project, right? Project selection. What is the capex? What is cost? I think it is not just about the capex and the opex. It is also about the output, and it is also about the, the ultimate objectives that we want to solve through that technological layer, right? So I think every technology will have its pros and cons. Not necessarily the technology which comes at a higher cost will have the low productivity or the low, output. And we know that, higher productivity and higher, sort of output comes at a premium price, right? It comes with probably a certain kind of various maturity in the technologies. So I think putting that piece of information on the paper, really deriving an analysis, I think it's very, very important before we select a technology. So I think what we do in Aarti is we have started doing so for, projects in the very, very initial stage, right when the project design is happening, there's a cross-functional collaboration happening. We do a lot of value engineering sessions. And there's a collaboration happening with the business partners, as we call them, So to understand what is their technologies in the market, what is the modular design that they believe are sort of, let's say, most techno-commercially viable for them. Because they also invest a lot of time in doing the engineering or the modules that they design, Some of the modules, for example, a compressor manufacturer may have a, let's say, a 1200 CFM compressor as a very, very, I would say, high moving item. A very standard design and which is sort of being manufactured for 80% of their customers, right? So I think all such information when we collect from our business partners and suppliers and then put it back in the projects, I think the transactional decision making becomes much more easier. I hope that answers.
Any counter to
Yeah.
technology options, low cost, high operating cost, low fixed cost, high operating cost, or high operating cost and low fixed cost? Initial cost is high, operating cost is low, initial cost is low, operating cost is high. When you do the technology options,
I would ask the audience here, in the learned people, what is the definition of technology? So, technology, basically, as per my understanding, is a practical, it should be practical, very practical. Plus, it should be easily reproducible, very easily. Like खिचड़ी बनाते ना इतना easily R&D में, pilot में, कहीं भी easily, very easily it should be, reproducible. And it should solve business problems. So solve business problems is cost, capex. So whatever, whichever technology, either is European, it's Chinese, in-house, whatever technology is practical and is low cost, is low capex, and you get a higher yield out of it, and is very easily reproducible. ऐसा नहीं होना चाहिए कि it can generate huge waste out of it. So if you calculate the waste, at the end of the day, it's costlier. So basically, that's what, in terms of technology, it may be, doesn't matter if your evaluation is being done by these ways.
So now we are left with only two questions. एक तो मेरे लिए आंसर करना है. क्या खत्म हो गया या? अच्छा. So I think we are giving enough tea, coffee here, and I think they are not planning to run away because of tea, because they are getting enough tea to the discussions that we are having. And Yogesh, it is their question that we are answering. Yogesh, it is their question that we are answering. हमारे तरफ से नहीं है क्वेश्चन ये उनके क्वेश्चन को ही हम जवाब दे रहे हैं. So the two questions which are remaining now is one is meeting timeline, managing manpower, so that the cost overrun or the time overrun can be managed. In a project, this is the कि आपने 200 करोड़ का तो ले लिया from the board. Now, when you complete the project, अरे 6 months का delay है, cost 50 करोड़ और ऊपर चला गया. So how do you manage this? Who would like to answer? Sir, Anil ji बोलिए.
So, I think first and foremost, we must recognize that I think industries at large have gone through various sort of issues, and manpower issues, I mean, when we say so, it's something which has become a perennial issue. It's not a new issue. It has become an issue which is there for last 25 years. Probably, forever the projects have lasted, some of the issues have also lasted that long. So, and with more so the public infrastructure investment getting, sort of a speed, and other governmental projects happening. And many of you or us are able to connect that, how the manpower banks, as we used to call them, typically, UP, Bihar, and some of the manpowers coming from there, Bengal, those states have also started investing a lot in the public infrastructure, wherein such resources are consumed at the source. Now, what is the fun for them to move out and, come to places like Gujarat when they are getting enough employment there? I think that remains one different problem than how it was existing previously. So I think one of the things that let's compare what China and other people did who invested massively in the projects and the infrastructure when they were chasing the growth, the way India is chasing now. I think the kind of productivity measures that they took, the kind of construction technologies that they had invested into, I think are very, very differently placed than how, as an Indian ecosystem we are doing. So just to give you an example, when we talk about, let's say, I think China comparison is inevitable here, but how they have invested into precast as a technology. The productivity when, I am sure, some of you would have observed when a precast yard, you would have seen the kind of productivity which comes out, and it is a factor of many, many things. When the daily wage people, they get stability in their life, they get a good sort of work-life balance, and I think the output goes to the next level. In the fabrication shops that we see as an output versus we see an output in the field, in the site, are very, very different. So I think enabling such kind of construction technologies are, I think, going to be the way forward. And as much as we adopt them and also are able to learn them and retrofit them in our projects or maybe, for the new greenfield projects, So we, as a company decided, certain things that typically, precast is not used in, let's say, in the chemicals sector so much, but there are oil and gas companies who have invested into, let's say, precast pipe rack, right? So we decided that, okay, let us build it for ourselves. Let us try. And we are also trying such kind of things even for the buildings, So I think that is something that we are experimenting with. I think it has given us a good result to start with, and we are hoping that we can take it forward. Yeah.
Any additional points on this front, or do we move to the next?
So, in order to reduce manpower requirement, we generally follow.
Just a minute, sir. Those who have not given their parchi, the lucky draw, please collect it from Yogesh and put it in the bowl so that we don't waste any time. Yogesh, if you can distribute, if somebody has not given. So you can continue.
Yeah. So those basically precast, what Anil said. So we generally adopt prefabrication structures and with 2-3 multiple vendors. So when our project starts, we give 3 different precast fabricators to start fabrication at their own fabrication workshop, so that we can fast fabricate the entire building. The second point is we used to keep some inventory at the site for growth projects, so that when you do HAZOP, you have surprises. Material कहाँ से आएगा, उसका वापस कैपेक्स लगेगा, वापस. So there we can save a lot of time. And and what Anil said is like, we are also evaluating different precast vendors to, construct the building fast. But at the end of the day, if your engineering, detail engineering is fast, you can release the drawings fast. So your fabrication starts fast. So zero date at the capex approval, your engineering should be completed. So that is the challenge we are having.
Thank you, sir. So now there are 2 questions remaining. One is how to integrate brownfield with greenfield so that we get the best output.
So I would say whenever you do, it's an organizational, objective, and it is better for all process engineering activities to standardize equipments. So, for example, this is a key parameter in, reducing the timelines of the project also. But standardization in the sense, I say, if you design a reactor with a, standard pressure rating, because in batch processes we have all standard equipments only. So if you design a reactor in a standard way, you can use it as a multi-purpose. You can modify whatever you want to do with that reactor, because the pressure is going to be the same, irrespective of any, special requirement if is there, high pressure rating and this thing. You can standardize the equipment and you can, modify in brownfield.
I just thought that I think brownfield and greenfield integration is something that the MSME sector is sort of quite excited about, and I think the way we are looking for agile execution, I think this has become one of the norm, right? So I mean, retrofit the product or retrofit the technology, we keep doing the same thing, right? So I think in that sense, I think your question was quite relevant, and I think my Kapilji have already answered that. I only wanted to add one point is that let's say the times or other few things that you asked. I think somewhere in the project life cycle, in my view, somebody knows that what is there in the offing. It's not that, people are not aware. For example, if the 4 products are there, if the 5th product is also there in the offing, I think the communication challenges are also quite a bit there in the overall project lifecycle. If we are able to understand and have the information parity right from top to bottom, I think certain things can be preempted. For example, probably that 5th product that you have not envisaged for, if a communication lands on the execution teams appropriately, I think there are enough technologies. You can do isolation, you can do many things. I don't need to answer that. So I think a communication challenge needs to be solved quite aptly there.
So I was just looking at what we prepared and whether it is matching with whatever questions that we were asked. I'm very open. The list is out here. I had asked my team, the panelists, challenges in terms of selecting right technology, futuristic project design, and planned execution strategies. This was common for all panelists, which was an introductory remark. Then the second was gaps in selection of new technologies, which you have been talking about. The third was on designing effective project design, keeping in view sustainability, renewable energy, waste management, water treatment, innovations and sustainability on the one hand, and modularity and flexibility on the other hand. So what he was talking about, we are talking on the same front. Only the buzzwords were missing, which was sustainability, the renewable energy, waste management, water treatment. Then the stakeholder alignment and adaptive strategies in terms to execution to ensure timely delivery of projects. We talked about manpower, time run, overrun, and cost overrun. Then prioritizing low carbon resource efficient technologies aligned with green chemistry principles, which is more on the sustainability part. Risk mitigation strategies to minimize cost and time overrun. Global best practices, which nobody talked about, but whatever we have been, these are what we can say, whether Jubilant, whether Aarti or Adama, they are all what we can say, some are multinational in nature, some are Indian multinationals, or planning to become Indian multinationals. So I think we are all in the right direction of global best practices. And one question which was, what is the scope of improvement for the Indian chemical industry on all these fronts that I talked about? So is the mother of all questions. So I think we are in sync with whatever you asked. We have tried to, so whatever design that we had done in terms of this particular panel discussion and whatever output that we got from you is more or less in the same structure. And scope of improvement. So you want to add? Yeah, please. Feel free, sir.
So one question was, not being elaborated. The gaps which we talked about in the technology selection, timelines reduction in capex, and escalation in timelines. So basically, see, you have to take project as you have a project with 700, 800 equipments and batch process. And if you say your team, I'm going to give a detail engineering order tomorrow, your team will be, you'll not be able to do anything. See, there are 4 parameters which you have to, consider. If you have to chase the timelines and you have to, squeeze the timelines. Organizational restructuring. You'll see in R&D, pilot, process engineering, project management, execution team. If you don't have the correct structure, you change it. You place right peoples in place. If you have, a chemist in the R&D, you have to have an engineer in the piloting who is, well experienced in tech transfer. The second point is digitalization. So you have to, give the resources to all these departments to, chase, because this is a very cohesive way of working. This project is a very cohesive approach of doing work. So everybody should be in the single platform. If you give softwares which are project, nowadays you have project tools like Wrench. So you can chase the timelines. The third thing is standardization. So standardization, if I'll say my team, you make 800 equipment PDS, then you take the offer of 800 equipment, then you tell Anil bhai to take the offer of 800 equipments. So the timeline which is there is 3 months at least for 800 equipments. And once you prepare those, once Anil bhai gives you the offer, once the PO is in place, then only the supplier will give you the drawings, GA drawings. And then those GA drawings you will give it to the consultant. Then he will start his layouting and engineering work. So it takes 4 months. So if you don't do standardization right at the CAPEX approval, you are already 4 months delay. So we have implemented this in Jubilant, and we have, so in 800 equipments, you are not going to standardize everything. So in 800 equipments, almost 60-70% you can standardize. All non-standard are like pumps and, small tanks and like that. So pumps are going to change. You can't standardize pumps. And the delivery of those pumps are not that much that you can worry about the timelines. So this way you can squeeze the project timelines 2-3 months earlier. So this is the third point is standardizing. The fourth point is capability development. So if your team is well versed, capability development, you don't have an R&D. In a small company you don't have an R&D. What you will do? So you have to have an R&D. You don't have a pilot. You have to develop a pilot. So all these 4 things, if you don't do, you are going to fail. This is the crux of my 23 years of experience in growth projects, not small projects, growth projects. That is all business-driven projects. So this was the point I was making.
So what I wanted to add is that design engineers should come and form a team with the chemist when the project is being validated. That is, we have 3 or 5 experiments to be demonstrated to the design engineer. So he understands what he has to look for when he is scaling up. So it is in R&D, the chemist is able to see through the reactor. It is a glass reactor. So he is able to show it to the design engineer who gets a proper insight what type of selection he is going to do for the scale up. So that one point I just wanted to tell.
He is absolutely correct. See, he is absolutely 100% correct. And through my years of experience, I'm having these issues. And these issues are, escalating. If I say, I get a data from R&D, and he writes that I have done distillation of a good example. I have done distillation of IPA. So if I review as a chemical engineer, the distillate quantity should be an azeotrope, because water and IPA is an azeotrope. But in the R&D data, it shows that 50% IPA, 50% water has come in the distillate. So I am little bit confused. So I am not a chemical engineer or he is not a chemist. So the challenge is, because a chemist doesn't know what is distillation. So if you do a reflux in the distillation column, then only you will get an azeotrope. If you have a bare distillation column, it will give or you will flash, you will get a 50% composition. So there are challenges. So you are very correct. So in that case, we have developed a template, a dossier sort of thing, what we require from R&D. And in terms of pure engineering data, where you are doing some distillation, you are doing some filtration, there our team is monitoring the data, and at the end of the day, we are responsible for that. So in the pilot, we are handling like filtration flask, we are handling the distillation rates, how much stages is required. So chemist will understand chemistry, and chemical engineer should understand engineering. So there is a gap there, and the industry needs, I think it should be from the learning scale, either in chemist or in the chemical engineering subject should be, tech transfer is a very big gap. Yeah, so you are very correct, but the tech transfer group should make a dossier with what data he requires, and he grabs only the chemistry part, not the engineering part. So
and it also validates
yeah.
that what is the end output.
So Praveen, once we get the data from R&D, so we are definitely going to validate. See, we are going to cross-check his norms and yields. So in the pilot, it is being
लड़ाई होनी है
validated.
वो पहले हो जाए.
Yeah.
बाद में
Yeah.
everybody will be happy.
So on that norms only we are validating, and we are, confident and bringing down the capex.
Sir, your last question from the audience, and then.
Sir, my name is Digvijay Chawda. I am from Make Money Industries Limited. My question is regarding the scope of process technology. Now we are working lots of process technology like gas phase reaction, continuous flow chemistry. It all are coming from outside of the India. So why we are not generating new process technology in India for the chemical reactions?
सर इसका जवाब दीजिए. नहीं, उसका देखिए बड़ा सिंपल है. If all of us come together, देखिए प्रॉब्लम क्या होती है. We all work in isolation. एकेडमिया बोलता है कि यार मुझे पता नहीं आपके बारे में. इंडस्ट्री बोलता है मैं आपको क्यों सिखाऊं. ठीक है. और उसके बाद फिर आप जो है डॉलर में पे करके आते हैं यूरोप और यूएस में, क्योंकि आप इधर सिखाना नहीं चाहते हैं, क्योंकि ये लोग सीख लेंगे तो आपका फिर क्या वैल्यू होगा. तो अगर सब लोग मिलके अगर एक साथ काम करेंगे. इंडिया के पास ड्रोन नहीं था, लेकिन अभी ड्रोन अटैक को उन्होंने एंटी ड्रोन से उन्होंने कैंसिल किया. अदरवाइज अभी कितने सिटीज़ हमारे अफेक्ट होते, कितने लोग मरते. सो एंटी ड्रोन एक्टिविटी भी ज़रूरी है कि अगर कोई ड्रोन आ रहा है तो हाउ विल यू ऑब्स्ट्रक्ट दैट ड्रोन सो दैट योर इंफ्रास्ट्रक्चर, वेदर इंडस्ट्री, वेदर फैक्ट्रीज आर प्रोटेक्टेड. इन द सेम वे डिज़ाइन इंजीनियर्स को आप डिज़ाइन नहीं देंगे. आप बोलेंगे नहीं मुझे तो भाई बाहर के लोगों को डिज़ाइन देना है, जितने भी कंपनीज हैं बाहर उनको देना है. जब यहाँ के लोगों को देंगे, यहाँ के लोग सीखेंगे तो ऑटोमेटिकली दे विल ग्रो अप. व्हेन दे ग्रो अप, L&T didn't become L&T multinational company just from day one. They took initial projects. Now they are focusing on larger projects outside India. It's the same way we have to come all together. And when you work in unison, I think those results will come into picture. जो मुझे लगता है. Any?
I will add, see, in terms of technology, if you'll say, China is at par. Yes, China lower cost, higher yield. If you say Europe, they are at a better technology than in the world in terms of flow technology and this thing. But somebody or as Praveen rightly said, that it has to be the government has to take the initiative, because we are not having this is a truth that we are not having good research in India. So all the companies are spending money on their own research. We don't have a common platform for research and learning. And sir's question was of a common pilot plant also. So all this these things has to be combined in a single forum where government has to answer these issues with respect to common facilities of pilot, common research centers. So it's an open question, still not not answered.
The only thing is, sir, we need to collaborate. Once we collaborate, a lot of things will just as R&D and what we can say project engineer are collaborating. So once you collaborate, things will, see, we do not know what would be the future. But once you start collaborating, you know how to minimize your problem statement. You know these are the challenges which will come. You try to overcome them. बाकी जो 10% है उसमें आप international help ले लीजिए ना. So anyway, that will help you in reducing cost.